So we are going to see a second problem which is based on horizontal translation. So in the first problem we have seen that is based on vertical. So we had y1 and y2. Here we are having an horizontal x1 and x2. I am going to rush a bit because we have seen the basics already. So here we are going to consider two components, m1 and m2, and m1 is connected to the components k1 and it has a friction b1, and it has an elastic element k and a frictional element b, and the displacement is x1. And when you are going to see the m2 has a frictional element b, elastic element k, frictional element b2, and it has a displacement x and an applied force f of t. So applied force is f of t is the input and the displacement x is the output. So here in this problem they have just said that determine the transfer function. So it can be either x of s by f of s or x1 of s by f of s. Either displacement can be taken, any one of the displacement can be taken. So we will take it as x of s by f of s. So we are going to draw a free body diagram for the first element, that is m1, first element m1. So when you are going to draw a free body diagram of m1, so we had nearly 5 components that is being connected to m1. There are 2 frictional component, 2 elastic component, and 1 mass. All of them are opposing forces that is being given into the object. So we will have an inward arrow mark, fm1, fb1, fb, fk1 and fk. So when you are going to write all those terms, fm1 equal to m1 into d square x1 by dt square, fb1 equal to b1 into dx1 by dt, fk1 equal to k1 into x1. When you see for fb and fk, when you notice the diagram, the frictional element b and the elastic element k, it is present between two displacements x1 and x. So we have to write it as x1 minus x. So when you are going to write an equation based on this fb equal to b into d by dt of x1 minus x, and fk is k into x1 minus x. So based on Newton's second law, we are going to add all those opposing forces and it will be equal to the applied force. Here we do not have any applied force, so it is fm1 plus fb1 plus fb plus fk1 plus fk equal to 0. So we will substitute all those values of fm1, fb1, fb, fk1 and fk. So those terms have been substituted here. So it is m1 d square x1 by dt square plus b1 dx1 by dt plus b d dt of x1 minus x plus k1 x1 plus k into x1 minus x equal to 0. This is 0 because we do not have any applied force. If we have an applied force, we will write it on the right side. So when you are going to take Laplace transform with 0 initial conditions, as I told you already, when you are going to differentiate a second degree differentiation, it will be something like s square into x of s. If single differentiation, it is going to be s into x of s. So here the first term will become m1 into s square into capital X1 of s. Second term will become b1 into s into capital X1 of s. Third term will become b into s into x1 of s minus x of s. Fourth term will become k1 into x1 of s. Fifth term will become k into x1 of s minus x of s equal to 0. So our intention is to find the transfer function capital X of s by f of s. So we will take the common terms of x1 of s and x of s and we will write it as equal to x1 of s, because our objective is to find capital X of s by f of s. So there is no need of x1 of s at the output. So we are supposed to find the value of x1 of s and we can eliminate it. So the value of x1 of s is x of s into bs plus k divided by m1 s square plus b1 s plus bs plus k1 plus k. This equation is marked as A. So we have found the equation by using the first object m1. Now moving on the second object, the free body diagram for mass m2. What are the opposing forces that the second object has is fm2, fb2, fb and fk, and it has an applied force, that is f of t. So we will write the fm2 value, fm2 equal to m2 into d square x by dt square, fb equal to b into d by dt of x minus x1, fb2 equal to b2 into dx by dt, Fk equal to k into x minus x1. So it has only 4 opposing forces and 1 applied force. We will see the diagram again to verify it, because that is more important. So when you are going to see the second object M2, it has one frictional element B between M1 and M2, and one elastic element between M1 and M2, and one frictional element B2, and an applied force and an opposing force based on mass. So we have 4 opposing forces and one applied force. So when you are going to write the equation based on Newton's second law, it's going to sum of all those opposing forces equal to the applied force. So it is Fm2 plus Fb2 plus Fb plus Fk equal to F of t. So we can write it as m2 d square x by dt square plus b2 dx by dt plus b into d by dt of x minus x1 plus k into x minus x1 equal to F of t. So by taking Laplace transform, as I told you earlier, the differentiation of Laplace transform dx of dt will give you s into capital X of s. So here the terms will be m2 into s square x of s plus b2 s into x of s bs capital X of s minus x1 of s plus k into x of s minus x1 of s equal to F of s. We will take x of s as common, equal to m2 s square plus b2s plus bs plus k minus capital X1 of s equal into bs plus k equal to F of s. Our objective is to eliminate x1 of s. So from a, substitute the value from a instead of this x1 of s. So the terms get bigger. So we can take the capital X of s as common, and we have to take a LCM. So the term will become capital X of s into m1 s square plus b1s plus bs plus k1 plus k into m2 s square plus b2s plus bs plus k minus bs plus k the whole square divided by m1 s square plus b1s plus bs plus k1 plus k equal to F of s. So we will move the right hand side term F of s to the left hand side and make it as a denominator, and we will move the entire bracket term to the right side. So our objective is to find capital X of s by F of s, and we have found the value. So capital X of s by F of s is equal to m1 s square plus b1s plus bs plus k1 plus k whole divided by m1 s square plus b1s plus bs plus k1 plus k into m2 s square plus b2s plus bs plus k minus bs plus k the whole square. So with this we have completed the mechanical translational systems, and we have seen two problems. One is horizontal and one is vertical. So if you like this mechanical translation problem video, kindly share it with your friends, and subscribe the channel, and click the bell icon to get constant updates. Thank you.